Afternoon, folks. Another deep thought by Jack Handey. Contrary to popular belief, the most dangerous animal is not the lion or tiger or even elephant. The most dangerous animal is a shark riding on an elephant, just trampling and eating everything they see. Another deep thought by Jack Handey. We're going to work on some deep concepts in algebra today, and they're a continuation of really solving equations. We've done it by graphing. Now we're going to do it using algebra. So our learning target for today is we're going to solve a system of two equations with two variables algebraically. And we're going to use these two methods, substitution and elimination. Here's an example of kind of a riddle of sorts, kind of a question that we are supposed to answer with algebra. Score on a trivia game is obtained by subtracting the number of incorrect answers from twice the number of correct answers. If a player answered a total of 40 and obtained a score of 50, how many questions did the player answer correctly? Well, let's just start out by assigning a variable. And we assign the variable by saying, really, we want to know how many questions they answered correctly. So let's say X is the numbers of correct questions, answered questions correctly. And if X is the number of questions answered correctly, Y is the numbers they got wrong, the incorrect ones. So let's just look at this and see if we can come up with a couple of equations and then go from there. So it says the score, and the score is 50. The score is calculated really by subtracting the number of incorrect questions from twice the number of correct. So right away we can write an equation like that. And we know there's a total of 40 questions, and if you added correct plus incorrect, that must be 40. So here's my two equations. What I want to do is solve them. And we could do it graphically, either using our graphing calculator or plotting it. But instead of doing that, since we know how to do that, we're going to use algebra. And in particular, we're going to use two methods, substitution and elimination. But right now, let's talk about substitution. That's where the first step is solve one of the equations for only one variable. Get X by itself, get Y by itself. Then you substitute that into the other equation. You're able to eliminate or combine somehow and evaluate what one of the variables is, and then plug that in again. So you substitute again, and then the last step is checking. So that's kind of our solve, substitute, check. SSSC. So here are the two equations that we created. What I notice is this one down below, if I subtract X from both sides, I end up with simply Y equals 40 minus X, or Y equals negative X plus 40. If I take that value for Y, and wherever I see a Y in the top equation, so in the other equation, I'm going to put in 40 minus X. What happens is I get 2X minus 40 plus X equals 50. When I combine like terms, I get 3X minus 40 equals 50. And when I subtract, well, actually, if I add 40 to both sides, I end up with 3X equaling 90. And if I divide both sides by 3, I end up with X equaling 30. That is my first part of the solution. It's an ordered pair. That's my X value. Then I take that and substitute it back in. The most easy thing to do is substitute it into this, because Y equals 40 minus 30. That means Y equals 10. Now, a check real quick is 2 times 30 minus 10 equal to 50. 2 times 30 is 60, minus 10 equals 50. Yes, that's true. And is in the other equation, that checks off. In the other equation, is 30 plus 10 equal to 40? Yes, that checks off. So what we solved for is really where the two lines intersect, but we used substitution and we found the ordered pair. And this is just, if you want to take a screenshot of that, that's how to do it kind of in a clean, organized fashion. So, I'd like you to pause and do this problem on your own. Thanks for pausing, coming back. Again, I look at this one and I go, okay, that one right there is kind of the easiest, because if I add 2x to both sides, I get y equals 4 plus 2x. Now, wherever I see a y in the other equation, I'm going to put in a 4 plus 2x. So I get 3x plus 8 plus 4x equals 1. 3x plus 4x is 7x plus 8 equals 1. If I subtract 8, I end up with 7x equaling negative 7. If I divide by 7, I end up with x equals negative 1. That's my first variable. It's my x value. Now, if I put that back into this equation right here, y equals 4 plus 2 times negative 1. So y must be equal 4 plus a negative 2, so y equals 2. Now you check in the original equations, is 3 times negative 1 plus 2 times 2 equal to 1? Negative 3 plus 4, does that equal to 1? Yep, it does. And in the second equation, negative 2 times negative 1 plus 2, does that equal 4? This is positive 2. Yep, that works. We solved it correctly using substitution. Now, just a reminder from when we were graphing, if you have parallel, if you have the same line that's graphed right on top of the same line, you will end up with a true statement and it's infinitely many solutions. If the lines are parallel and never intersect, you'll end up with an untrue solution, and that's what we write. So just notice that. Go ahead, pause, look at this equation, and hit play when you're done. So in this one, what I notice is that this equation here is kind of nice to work with, because if I add y to both sides, what I end up with is x equaling y plus 4. Don't usually have it in that form, but it's just another way to do it. So wherever I see an x, I'm going to put in a y plus 4 in this equation. Negative 6 times y plus 4 plus 6y equals negative 24. When I distribute, I end up with negative 6y minus 24 plus 6y equals minus 24. The terms combine and get to be 0, and I end up with this statement. Is that true? If it is true, yes it is. That means that we have infinitely many solutions. Okay. Second method is the elimination. And what we do is we look at the equations and figure out, what do I want something to add up to? And it's usually I want it to get rid of it or eliminate it. It has to add up to 0. So I'll multiply one or both equations by a number so that the coefficients that differ only in a sign of the one variable will add out. They'll add to 0. Then you'll substitute what you find for that variable the value for the variable back into the other equation to get the second one, and then you check. So that's a real quick, kind of confusing way to explain. Let's see it worked out. Right away with this one, I notice I don't have to do anything to either of them. I'm just going to add the columns straight down. And what I end up with is 3x, the y's cancel out, equals 90. I divide by 3, and x equals 30. I take this x equals 30 and put it back into one of the equations, doesn't matter which one, and I end up with 30 plus y equals 40. I subtract 30 from both sides, and I find out that y equals 10. Now, this was an example from before, and we did check it, and we found out that those were the solutions, so I'm not going to take time to do that. We're going to look at another one using elimination. This is one where there isn't something that, when I just add the columns, cancels out really nice. But what I notice is I wish this top equation, I wish that this was a negative 6x plus 6x, that would end up to be 0. So I ask myself, what do I multiply 3x by to get negative 6? And I say negative 2. So then I just pull it over here. Let's see, it'll be negative 6 plus 14y equals negative 20. And then I just pull the other equation over, and I'm going to add the columns. Here, this adds to 0. This adds 14y minus 8y is 6y. And over here, I end up with negative 12. So when I divide by 6, y equals negative 2. So I just want to put that back into one of these original equations. And solve for x. So 6x plus 16 equals 8. Let's see, it looks like I subtract 16. 6x equals, because this is 0, negative 8. If I divide by 6, x equals, put this in lowest terms, and it looks like it's negative 4/3. So my ordered pair looks like it's that. Now, when you check it, you'll notice that indeed true statements happen. And so we found the right one. Let's look at this one. This one is probably the most complicated one in the section, in that, I ask myself, what do I multiply x by so that it cancels out with a 6x? What do I multiply 2y by so it cancels out with 5y? And typically we don't want to do decimals. You can, but it's just not as clean. So what I'm going to do is I want to say to myself, what number does both 4 and 6 go into? And right away I think, okay, both of them go into 12. So if I multiplied this by 3 and this one down here by negative 2, here is what ends up being my system of equations. I end up with 12x minus 15y equals 39, and negative 12x minus 4y equals, I think that's negative 96. When I add these columns, the x's go to 0. I end up with negative 19y, and here looks like that's going to be a negative 57. When I divide by negative 19, I end up with y equaling a positive 3. So my first number in the ordered pair is 3. Then I take this and substitute it back into one of the equations. And so 6x and one of the original ones. So 6x plus 6 equals 48. I subtract 6, and I end up with 6x equaling 42. Divide both sides by 6, and x equals 7. So my ordered pair is 7, 3. What you should find out is when you check it, indeed it does work. We should always do the check. And that'll be a part of your summatives is checking it. Make sure you do that. Last problem that we want to work at is we got a pizza place. It costs $4 to make a small pizza and they sell it for 12. It costs $6 for a large pizza, but they sell it for 15. In 1 week, the restaurant spent a total of 1,100 making pizzas and sold all of them at $29.10. How many small pizzas were sold? Well, let's just say, to begin with, that the number of small pizzas is S. The number of large pizzas is L. And so if I take this information up here and put it in the form of an equation, $4 times the number of small pizzas is the cost of making the small pizzas, plus the cost, $6 times the number of large pizzas. The cost of the small pizzas plus the cost of the large pizzas is $1,100. Then the sales equation is they sell them for $12. So if I take 12 times the number of small pizzas plus $15 they sell them for times the number of large pizzas, that's going to be my total revenue for the large pizzas. What I'd like you to do is go ahead and solve that system of equations. When you are finished, hit play again and I'll show you the answer. I won't actually go through the work, but I'll show you the answer. Thanks for doing that. Okay. Looks like if we multiplied the top equation by 3, and let's make it a -3, this is what we would get down there. I add, get rid of the s's, they're gone because it's 0s, and I just end up with this, and I find out that L equals 130. I put L equaling 130 back into one of the equations. I chose the top one, put 130 in right here, multiplied it out, ended up with S being 80. And remember, we wanted to know how many small pizzas were sold. And so this is the way we write it, selling 80 small pizzas, and we label our answers. So what we've been talking about is solving systems of equations using substitution and elimination. Remember, if you end up with a true statement, it's infinitely many. If you end up with a false statement, it's no solution. Try these on your own as practice. Thank you. Your assignment for 3.2. We have been learning how to solve linear systems of algebraic equations. When you're finished, make sure that you check your answers on the answer sheet, and we will have you turn in your worksheet by submitting it through Schoology. Not right before the test, but at my due date. Thanks for